I'm Chip. Let me see, how does this work? Okay. Thank you so much for having me here. I've been like a big fan of PyTorch for many years, so I'm really excited to be here today. So the talk today is why you should think twice before adopting an evaluation tool. True warning, anyone here is building an evaluation tool? Okay, so I was worried about this talk a little. I was like, would I offend people? And I did a dry run with like Sumit yesterday. He was like, nah, go for it. So if you're upset, blame Sumit. Okay, so I do think that's like, even though a lot of people might adopt AI for hype, I think the vast majority of business decisions are still driven by return on investment. It's very hard for companies to deploy an application unless they can see clear returns. So I call this like evaluation-driven development. It's like companies could focus on applications so that they can evaluate and measure outcome. So it's not a surprise that like the most popular AI use cases today are the use cases where you can actually see very clear returns. For example, recommender system, right? Like you can recommend and you can tell whether it's working if you see like increased engagement or like higher purchase through rate. Fraud detection is like if you can stop fraud, you can save money. And another thing is like coding. I think coding is definitely like popular for many reasons, but one of the reasons is that you can actually evaluate based on functional correctness. Like the AI can generate code and you can just run it through a lot of unit tests or like integration tests, very common software engineering. So I do believe that like, why is this like a good approach? It can also lead us to a situation where you try to like find the key under the lamppost because this is where you can see the light. So we are constrained by like what applications that we can evaluate. And I do believe that like being able to like evaluate better will unlock many, many interesting use cases. However, LLM evaluation is hard. So it's hard for like many reasons, but like I think let's go over two of them. One is that the more intelligent AI becomes, the harder it is to evaluate them. So anyone, like most people can evaluate whether a first grader math solution is wrong, but it's much harder to like look into a PhD level math solutions. I'm not sure you saw the recent post by Terrence Tao, a Fuse medalist, and he was just like, okay, it's like the experience is similar to advising a mediocre but not completely incompetent graduate student. And I really love the comment after that. It was like, if we are already at the point where we need the brightest mind to evaluate AI, then we will soon be like out of qualified people to evaluate future AI iterations. So another reason is that open-ended evaluation is like much, much harder than like traditionally like classifications. So before, right now, if you have like 3 options and if you choose the other option, you know it's wrong. But with open-ended evaluation, it can go like many, many different ways. So think about the use case of book summarizations. So if the book summary sounds okay, like sounds coherent, you don't really know if it's bad or not until like maybe you have to read the entire book to evaluate it. Or like if it asks you to like generate some arguments about like why vaccines does not cause autism, right? You need to like go and verify, fact check on the reference that it generates. So it becomes extremely hard. So because this is hard, that there's been explosions of like evaluation tools built to like, help company do this. So this is some fun project I did. So it was like tracking like all the tools like built for evaluation, and you can see clear like jump in evaluation tool just after ChatGPT came out. So given that evaluations is really hard, and the availability of evaluation tools is very tempting for people to just jump like straight to adapting tools. So I do believe that I'm a big fan of tools, and I actually like building tools in my free time. And I do think that like the right tools can make the life a lot easier. I do believe that sometimes introducing tools too early can actually cause more problems than not. So for example, like before we adapt a tool, like evaluations, maybe we should take a step back and try to understand like what are we trying to do, like what kind of things we are trying to evaluate. So evaluations is to mitigate risk and uncover opportunities. So to mitigate risk, we need to understand what the risks are. So one thing I have a lot of companies coming to me and say, like, okay, evaluation is hard. Our evaluation system is not good. What do we do? And I was like, why do you say the evaluation is bad? Because when you say evaluation is bad, it usually means that there are certain failures that you should have caught, but you didn't catch. So I was asking them, like, so what kind of failures that you wanted to catch, but you felt like the system didn't catch? And a lot of times it was just like, I don't know. So on first things, it's like, we need to be able to define, like, very clearly what failures look like. So it's a very interesting case study from LinkedIn, and they said that, like, on their reflections after a year of building AI applications, and they said that the hardest thing is to define the criteria for, like, what good responses are and what bad responses are. Because a lot of time, a response can be good, like be correct, but entirely, like, not helpful. So for example, they built this app, chatbot, to help candidates assess whether they're a good fit for a job, right? And the response is like, you're a terrible fit, is a correct response, but it's not a good response. And it needs to be able to define that failure mode. So another very common failure mode that I see is, like, hallucinations. So who here thinks that hallucination is a big issue for LM in productions? Okay, about half. So you know what is coming. It's a trick question. So who here can tell me what hallucination is? Really? I'm not gonna call on you, I'm just like asking. Okay, so I see this like one like very hesitant hand, thank you. So that's very common. So there are a lot of things we still don't know about hallucinations, but also there are certain things that we do know about hallucinations. Hallucination, even though it has captured a lot of imaginations recently, is not a new problem. So if you come from like NLP background, like in the NLG, like natural language generations, hallucination is a pretty old, long-standing problem. It's related to natural language inference. So the idea is that given a statement and a given hypothesis in a statement, can the statement be derived from the hypothesis? So like the entailment, because entailment means that you can derive the statement from the hypothesis. If it's contradiction, means that like it's completely contradictory, and it's neutral means that no, there's no relation, that you can't really determine yes or no. So there are things that we know about hallucinations, right? So let's try a quick quiz here. Like, so I have like two queries I want to ask the model. So the first one is, when was the International Mathematics Olympiad in 2007? And the other is the same questions, but about the Vietnam Mathematical Olympiad. So who thinks that the model is more likely to hallucinate on the IMO question? So nobody? So who thinks that the model is more likely to hallucinate on the VMO questions? Okay, so more people, right? I wish I could ask people why. So I think this it's a pretty well studied and well researched problem that the model is more likely to hallucinate when being asked more niche questions. Like the information that like unlikely or like very rarely appear in the training data. And you can probably see that, for example, like yes, it did. So I asked like a one preview, and it did hallucinate on VMO, but like got it correct on the IMO. So it's not entirely like all the way true, because of public nature, if you can actually like bully it into like saying the wrong things, because if you keep asking, it's like really, it would change its answer. So actually like a fun benchmark I want to do is like how bullyable an AI is. Like if you can just like gaslight it, how often it changes answer. So we do understand something about hallucinations, and what I want to say is that it's very important. Like if we think hallucination is an issue, we need to like look into the failures, like different instances of hallucinations, and understand for what types of queries the model is more likely to hallucinate on, and build our benchmark evaluation metrics around those. And it's not gonna be like pain and suffering. It's not something that you can just like ultimately outsource to like a tool. So there are many different ways that a system can fail. But in general, like that based purely on the response. I'm not talking about latency, cost, or security here. That's based purely on the responses. I usually categorize the failures into information-based failures. It's like, for example, like when it's factually incorrect information, or the information that could have been factually correct at some point in the past, but now it's like outdated. The other very common failure is called like behavior-based failures. It's like one thing is like, one example is when the response is factually correct, but it's just not relevant. So example of like here an example, like if you ask AI why retrieval is important for AI applications, it might answer by like retrieval is a technique for search and access. So which is correct, but it's not relevant because it doesn't answer why. So another very common form of like behavior-based failure is just based on format. Like if you ask is, should I generate a JSON file with 2 keys, title and body, and it's just like generate like not possible by JSON, or just wrong keys, so it's not, it's a failure mode. So you can define a lot of different failure modes, and it can help you build some metrics around that. For example, like maybe in the last iterations, it generates like 80% correctly formatted responses, but this iteration is like 92%. So once you define all these kind of failure modes, it's a lot easier to define the metrics that we can use tools to like automate and like build dashboard for. Another thing is like important to understand is like where the system fail. So an example that I actually see quite a lot. So here your resume, but like you can also like use like in documents as an example. So first of all, like if the user gives the system a resume and a questions like where has a candidate worked, and the system's output like Meta and Google and missing an employer. So we need to understand just like where in the system does this fail. So you need to look deeper into the system and different components. So let's say like this system used like first a resume parser, and then it extracted the text, and then it used the extracted text to generate the response. So maybe you want to check first, like how accurate is the resume parser. Maybe the problem is that the resume parser just like didn't get the corrected text, or the problem could be with the parser, because like the extracted text is correct, but the answer is incorrect. So different kind of understand where the system fails and have you like localize the problem and like improve the system. So I do think that evaluation is it's just not about like detecting failures, but also help you like figure out the right solutions for the failures. So I do think that like tools can be immensely helpful. However, like introducing tools too early before you understand the system can actually distract you from the main problem. And sometimes I can also like introduce more variants because every tool developers has their own taxonomy and ways of doing things. And when you adapt a tool, you're going to have to get used to it, have to learn it. And sometimes it can point you in the wrong directions. So like I've seen a lot of evaluation tool demo. At some point in my life, I was seeing like 2 or 3 every week. And one of them, like a lot of them use some variations of like LM as a judge technique, like using AI to like evaluate models. And a lot of them have some like similar sounding criteria. So like one example like faithfulness. So like if you have the RAG system, you retrieve the context and you generate answer, and you want to like measure like how faithful the answer is to the context and the original query. But like using AI as a judge, right, you need not just a model, the AI model as a judge, you also need a prompt. So we're trying to look into like how these different tools evaluate faithfulness. And just realize it's like for every single of those evaluation tools, the prompt is different, and even the scoring system is different. So like if you just use a tool, you kind of bought into this whole ways of doing things, and it could actually like make it harder. It can make it harder for you to understand what the core problems are. Evaluation is to mitigate like risk and failures. But failures might not be solved by evaluation alone. So one example I usually ask people is that like, let's say you hire an intern to do some work, and that intern failed at their job. Like, who do you blame? So one option is just blame the hiring process for not being able to like identify the right intern, or you can blame the intern for not trying hard enough, or you can blame the manager who just doesn't know like how to assign a task that the intern can do. So I do think it's like the first one is like the hiring process is when you like put the responsibilities on evaluations. And if you blame the intern, it's like you are blaming the like system developers who build model, who build the applications. Or as a manager is when you blame the users for just not knowing how to use the systems right way. So evaluation can certainly is one way to have you mitigate failures. But you can also do it by other ways. So you can work with the system developers to make the system more robust to failures, or like make it more observable so you can understand and trace down when something fails. Or you can work with users and educate them so that they can know how to use the system better. So yeah, so evaluation is a system problem, and I do think the first thing is to figure out what failures look like and understand what failures, where in the system failure happens, and you can design the system to mitigate failures, and then you design metrics to get failures that the system design cannot solve, and only after that we adopt the right tools. Oh, sorry, I think that I have the obligatory, I work at Voltron, and we work on data processing on GPUs, and we have this really cool benchmark to show that if you move the large amount of data from CPU, like Spark, to our system, it's a lot faster and a lot cheaper. And I also have a book coming out soonish on engineering, but that is pretty much it. Thank you so much, everyone.